Okay, so continuing with the problem we were working on before. So we've gotten through the hard part of looking at the carbon-carbon bond breaking. Now we're going to look at this other piece here, which is just looking at functional group transformations. And these are easier, like I said, but they still require some work. So we get some functional group transformations we're going to try and do here. Okay, so yeah, we've already done the bromination of this, radical bromination of this propane molecule, and now we are going to take a look and try to keep moving. So in my mind, because I just know this, and I encourage you to just know this as well by just memorizing it, because I gave it to you in the last video, or the video where we added some extra reactions in that weren't radical reactions. I would just suggest kind of knowing this recipe because it's a very, very, very useful recipe. Okay, so then I can take LDA and make the alkene, and then I can brominate it. Oops. I can brominate it to make the vicinal dibromide. And then I can just use LDA in a large excess. If you go in the book, they talk a lot about the stoichiometry for that. I'm not going to bother you with that right now. And what I get out of it is this, okay? Which is exactly what we wanted to get. We wanted to get this product out, and so we see that we can get to this acetylide anion in, let's see, 1, 2, 3, 4 steps, okay? So starting with an alkene, I can always get to acetylide anion in just 4 steps. If you want to think about the logic behind this, because I just kind of just wrote it down, if you want to think about the logic behind this, the first step, I'll mark them out in different colors. This first step, I have an alkane. I don't have any options of what I can do there. Right? I have to use radical halogenation, which I do. And that gives me an alkyl halide. I literally don't know any other reactions I can do there. Okay? Now, I know that ultimately from there I want to make an alkyne. Okay? I only know one way to make an alkyne, and that is to use a vicinal or a geminal dihalide. So I know I need to make this, okay, somewhere along the way. The way that I know how to make a dihalide is from an alkene. So I know that I have to have an alkene. And then of course I know to make an alkene, I can just take the alkyl halide and use a base to make it. And then ultimately, that allows me to get to the alkyne. So there's a rationale that's going in there. And you're just trying to use, you're trying to like kind of chain reactions together, daisy chain these reactions together to get you to where you need to go. So, you know, if you're thinking about like what you'd like to be able to do, right? If I needed to make the acetylide anion, it'd be really great if I just had some reagent that allowed me to go directly from the alkene to the acetylide anion. But that's just, we just don't have that kind of chemistry. And that's, you know, that's not how the world works in general. You can't just take any singular thing, convert it into something else in a single step. You know, yeah, like looking at, trying to think of some, like a house or something, right? I can't just take like cement and then be like, okay, I want to take this cement and just like do one thing to it, and then now it's a house, right? There's a whole series of steps that goes into building a house. I take the cement, I pour a slab, I take a frame and I get some lumber and I frame up the house. I put on all this other stuff, right? And this is the same thing for organic synthesis. We can't just magically go between two things because we'd like to. We have to take this series of steps, and the limitations there are just kind of what's available to us. So just like you're limited in the materials you could use to build a home, you're limited in the types of materials and reagents and tools and things you have for doing organic synthesis. So, but this is how you make an alkyne. This is the recipe essentially for an alkyne. It's really the only way, or it's a very useful There might be one or two other ways, but this is the most useful way to make an alkyne. So if you start with an alkane, you can make an alkyne. If you start with an alkene, you can also make an alkyne, right? You just need to know how to push basic materials towards getting an alkyne. Okay, so that gets me to the acetylide anion, which I'm using that term interchangeably with an alkyne. And now our other thing that we need to make is this, right? So the question that we're asking is now, how do we go between that to that? Okay, so again, because it's an alkane, I don't even have to really think at all about what my first step is going to be. I only know this one. And unfortunately, it gets me close, but it doesn't actually get me there, right? Because if I look at this, I have the bromine is substituted at the primary carbon, the terminal carbon. Look at this one, it's at the damn secondary carbon. So we're going to have to do some stuff because we need to move it around. So here we're going through again, we're going to just do a bunch of functional group transformations until we can get a primary alkyl halide. So you're going to be drawing on this database that you created in your brain of different reactions to follow. Okay, I'll try and walk through my logic a little bit more cleanly here. So I want to make this, if you want to think backwards, because that's always the place to start if you have no idea what you're doing. You could say, well, how would I make this, right? And we know how to make that. We can make that by using an alkene. The reagents that you'd use for this would be HBr and peroxide. Okay? So now it's just a question of like, okay, well, all right, so I want to make a primary alkyl halide. I know I need an alkene. How do I make an alkene? Well, remember the only way that we know how to make an alkene is if we're starting with an alkyl halide. If we're starting with an alkyl halide and we're using some sort of base. And so at this point it becomes kind of silly to go back any farther because, like, you know, I don't know, what's the alkyl halide going to look like? You have to use your starting material to kind of inform that decision. And that's where this piece down here comes in handy. I know this is where I have to start. And look at that, I have an alkyl halide. So I can just add in some LDA or some sort of base, and now I have my alkene. And then, as we just discussed, I know I can just take an alkene and take some HBr and some peroxides. And now I have the alkyl halide that I wanted. So that's your strategy for making that subunit. Okay? So now we got to put this all together. So if you were, if you had a written exam, you would put it together something like this. So the question, remember, was how do I take this and make 1, 2, 3, 4, 5, 6 this? How are we going to do that? Okay, so we're going to use the retrosynthetic analysis that we did for the carbon-carbon bonds. We're going to kind of put this whole thing together. Okay, so we're going to start by showing our transformation of this to form the two fragments, and then we're going to show how to put those fragments together. So this is, we've already worked through the problem, I'm just showing you how to kind of write it all down. But yeah, so this is our first step for either of those fragments. We do this. From here, you want to take, you don't have to do this reaction. If you do it once, you don't have to write it out twice. From here, you'd want to split that and take that material on two different pathways. So I'm going to take this, part of this, and I'm going to use LDA. I'm going to make the alkene. Actually, you could probably split it at that point, right? Because we have to do that for both of these. Then I'm going to take that alkene and then I'm going to split it. Part of that alkene I'm going to take and I'm going to add Br2 to. And then I'm going to use a large excess of LDA. And that gives me the acetylide anion. Then I'm going to take the other bucket of alkene that I separated out. And I'm going to take it, I'm going to add HBr and some peroxides. Okay, so that gives me my two carbon fragments that I want. And now remember, we want to join these together here and here using our alkene, our acetylide anion alkylation scheme that we learned. And then, so yeah, that final reaction step just looks like this. You don't, sorry, let me avoid doing this because I don't want it to be confusing. You don't have to draw the mechanism out. That's just what I do. So yeah, so you want to combine these, and now we get this, which is very close to the product we wanted, right? But remember, the product that we actually want doesn't have the alkyne in it at all. Okay, so we have to take this thing through one more functional group transformation, and that is to use hydrogen gas and platinum. And that finally gets us to 4, 5, 6, just this standard looking alkene. So pretty laborious path to get between a 3-carbon piece to just kind of attaching another 3-carbon piece to it to form this 6-carbon chain. And there's probably, industrially, there probably are better ways to do this. But on a lab scale, these types of reactions are really, really common. Because in a lab scale, you're not optimizing for, money and time in such an extreme way, because you're not making giant vats of this type of stuff. You're just making little bits and pieces so that you can probably take those molecules on and study them for something else. But yeah, so that is how you do organic synthesis. And you can see it's not trivial to solve these problems, but they can be pretty satisfying once you sort of get the hang of it. And I'll work one more of these problems in here in a different video. But that should get you started with some things to think about. And what you'll see is, if you work all the problems, and I strongly, strongly recommend you work all the problems in the workbook and check with TAs and stuff during office hours, you'll start to see a rhythm that it's not as open as it feels like. It's just like the same thing over and over again. And eventually, hopefully, when you're doing it well, you're almost kind of bored with it because you're like, oh, I've seen this, I've seen this, I've seen this, I've seen this. So it'll take some work to get there, but just trust me, you'll get there. Okay.